Can you model a phone using only modifiers? Hi, it's Ian from Huge Menace, and I'll show you how this is possible in Blender. To achieve this, we'll be using our free add-on for Blender called ND. ND makes it easy to model using a non-destructive workflow. We'll start by defining what non-destructive actually means, then set up our scene in Blender, model the main shapes and forms, and add components and details. Once our model is complete, we'll set up shader materials, lighting, and create a nice rendered result. Okay, so what is non-destructive modeling workflow? Well, instead of making permanent changes during each step of the modeling process, a non-destructive workflow allows modeling operations and parameters to be changed at almost any time. Let's look at a simple example. If I wanted to bevel this cube, I could select it, enter edit mode, press Ctrl B, and then set the width. Before I commit to this choice, I have to be confident this bevel width is correct, and I won't need to adjust it later. It's not impossible, but it is annoying. However, there is an alternative. Modifiers allow us to perform the exact same task, but let us change parameters at any time. They provide us the ability to make procedural changes to the underlying mesh, whilst not destroying that original mesh data. This is the meaning of non-destructive. I'm going to show you how you can start with simple mesh primitives and use the power of the modifier stack to create a much more complex model, like a mobile phone. Let's begin with a ritual sacrifice of the default cube. With our sins forgiven, open the Blender Preferences menu and ensure you have the Huge Menace ND add-on installed and enabled. There's a link to download ND in the description below. Open the Scene Properties tab and adjust the units to something that's easier to work with when modeling small parts of a mobile phone. I'll be working in millimeters. Because we're working at a small scale, it's also a good idea to adjust the viewport camera settings. Open the View sidebar and change the clip start and clip end to lower values. We're going to block out the basic phone shape with a mesh primitive. Press Shift-A to add a plane, press N to open the Transform sidebar and adjust the dimensions of the plane. I'm going to zoom in by pressing period on the numpad. The object scale has also been affected, so let's reset this by pressing Ctrl-A to apply the scale. Phones usually have round corners, which is how they trick you into thinking they're harmless. So let's soften those pointy bits with a vertex bevel. Enter edit mode and ensure all 4 vertices are selected. Press Shift-2 to open the ND add-on and choose Bevels, Vertex Bevel from the menu. This opens the ND Interactive Overlay, where you adjust parameters before applying the operation. To set a precise bevel width, type in a value on your keyboard. Next, hold down Alt and type in a value to set the number of bevel segments. Left-click or press Enter to confirm the operation. If this is your first time using the ND add-on, you might be wondering what just happened. Let's open the modifier stack to see what's going on. ND has added and configured several modifiers for you, including a bevel modifier. Go ahead and inspect the bevel modifier to change either of the parameters we just set. ND works by adding and managing modifiers as you work in the 3D viewport. But it's also fine and sometimes necessary to make manual changes too. Next, we want to add some thickness to the basic phone shape. Returning back to object mode, press Shift-2 and select Extrusion Solidify. Type in a value to set the thickness. Then left-click or press Enter to confirm the operation. This looks good so far, but I also want to visualize the mesh geometry so I can make clear decisions about the details. ND can help with this. Press Shift-2 and choose Viewport Wireframes to toggle this on and off. Later on, I want to do some close-up renders of the phone. If I zoom in to check this quickly, I can see the number of bevel segments may need to be adjusted later. But during the modeling process, it's a good idea to be economical with mesh density. Try to only use whatever is needed to establish the basic form. The good news is that we used a modifier. so we can come back later to increase the segments and smooth it out if needed. This flexibility is one of the huge advantages of a non-destructive workflow. We're going to duplicate this mesh a few times and reuse it for several parts of the phone. So let's get organized. Rename the mesh to frame and rename the collection to model. I want to cut a hole right through the mesh to turn it into the outer metal frame of the phone. To achieve this, we're going to use booleans. Press Shift-D to duplicate the mesh and right-click to confirm whilst leaving it in the same position. Rename the duplicated mesh to Frame Inner Cutter. With the Frame Inner Cutter still selected, open the Transform sidebar and adjust the dimensions so that it's slightly smaller than the frame. Press Ctrl-A to apply the scale. Before we use this shape to cut a hole through the frame, we need to make it thicker. Press Shift-2 and select Extrusion Solidify. ND detects the existing solidify and goes into recall mode, allowing us to increase the thickness. With the Frame Inner Cutter still selected, hold down Shift and left-click to add the frame to the selection. Press Shift-2 and select Booleans Difference. This looks okay, but if we switch to the top view and zoom into one of the corners, we can see the inner radius of the corner is too large and makes the frame look chunky. Let's fix that. Press Shift-2 and choose Bevels, Vertex Bevel from the menu. Adjust the width parameter until the corners appear to be the same thickness as the straight edges, and press Enter to confirm. Return to Object Mode when you're finished. To keep the outline of view clean, ND has organized our Boolean Frame Inner Cutter object into a handy utils collection. In the 3D viewport, this cutter utility is also visible as a wireframe in case we want to make any further adjustments. This can be quickly hidden by pressing Shift-2 and choosing Viewport, Utils, Visibility. The frame still looks a bit sharp, so let's soften the outer edges so that it would be more comfortable to hold in your hand. Select the frame and press Shift-2 and select Bevels, Bevel. You'll notice that as you increase the value, the outer and inner edges will begin to overlap. I only wanted to bevel the outer edges, so I'll left-click to confirm the operation and think about what to do next. The solution lies in considering the specific order of modifier operations we've applied to the mesh. With the modifier stack open, we can see the bevel and weld modifiers have been added, but they've been placed lower in the stack below the difference boolean. ND tries its best to organize modifiers automatically for you, but sometimes we have to make changes manually. Drag the difference boolean modifier down below the weld modifier. Now you can see only the outer edge of the frame is being beveled. Before we move on to a final level of detail, it's good practice to block out the other main parts of the model first. Let's start by adding an inner body to fill in the bulk of the phone. This body mesh will become useful when we add materials later. Instead of creating this from scratch, we already have something that is perfectly sized to fit inside the frame. With the frame selected, press Shift-2 and choose Cycle. The cycle operator will cycle through all the Boolean utility objects affecting our current selection. In our case, where only one Boolean has been applied so far, it quickly reveals the Frame Inner Cutter. Left-click to confirm and make it visible. We can turn this into a useful piece of geometry. With the Frame Inner Cutter selected, press Shift-2 and choose Booleans Hydrate. The Hydrate utility will take any utility object and duplicate it, restore its viewport visibility from wireframe to shaded, and place it into the scene or selected collection. By scrolling with your mouse, choose the Model collection and press Enter to confirm. You'll find the mesh already parented to the frame, so rename this new mesh to Body. With the body selected, press Shift-2 and choose Extrusion Solidify. Adjust the thickness to a value that is slightly smaller than the height of the frame, and press Enter to confirm. The Frame Inner Cutter Boolean utility is still visible, so you can hide it by pressing Shift-2 and choosing Viewport, Utils, Visibility. Okay, to create the rear panel surface of the phone, we can duplicate the body with Shift-D and then rename the duplicated mesh to rear panel. For the next few steps, it's going to be easier to see what we're doing from the side view. Toggle the X-ray view by pressing Alt-Z and we can see through all the objects. With the rear panel still selected, press Shift-2 and choose Solidify. Pressing W twice will switch the weighting to negative. Hold down Ctrl and scroll your mouse to offset the mesh downwards until it aligns with the bottom of the body. Let go of the Control key, then scroll or type in a value to adjust the thickness so that the mesh is a thin part fitting snugly into and flush with the bottom of the frame. Press Enter to confirm. For the glass, we can repeat the same steps. Start by duplicating the body, then rename this new mesh to glass. Adjust the thickness by pressing Shift 2 and choosing Solidify. Let's rotate our view back to a nicer angle and toggle off X-ray view by pressing Alt-Z. With the glass selected, press Shift 2 and choose Bevel. Scroll to increase the radius until the edges start to overlap each other. Then press C to automatically clamp the width and prevent the edges overlapping. Hold down Alt and then increase the segments to get a nicely rounded result. This looks good, but it doesn't quite fit snugly into the frame. We should tweak the width and height because otherwise a tiny imperfection will haunt us forever. Just remember to press Ctrl A to apply the scale. Giving in to the madness of perfectionism is cheaper than therapy, so we better adjust the vertex bevel on the corners to avoid a sleepless night. The next part we need to think about is the display. This will sit below the surface of the glass once we've set up our materials. Start by hiding the glass mesh, then duplicate the body again. We don't need the display mesh to have any thickness, so we can remove the existing Solidify by pressing Shift 2 and then holding down Ctrl just before we choose Solidify. This is a common shortcut in ND that lets us remove operations. Alternatively, you can manually remove the offset and Solidify from the modifier stack. We want this display mesh to sit above the body, so let's reposition it until it's just level with the top of the frame. If we switch to top view, we can see that we may want to consider insetting the screen slightly from the edge of the frame in order to create a black display bezel. You already know how to do this, so go ahead and tweak the width and height of the display mesh. Don't forget to press Ctrl A to apply the scale. If you don't, your vertex bevel may appear uneven. We should probably also tweak the vertex bevel width. Okay, this is looking good. We've completed all of the largest shapes and forms of the phone. So it's time to move on to components and details. The frame has the most components, so we'll start detailing here. Hide all the other objects so we can focus. First, we need to add these tiny plastic gaps known as antenna lines. Without them, your phone would have much crappier signal strength. Let's add these antenna lines to the frame. We're going to do this with the help of a special kind of operation called a slice. We'll need something to slice with first, so press Shift A and choose Mesh, Plane. Set a more practical size to work with, then rotate the plane 90 degrees on the X-axis. I'm also going to reposition it along the Y-axis closer to the end of the frame. Press Shift 2 and choose Solidify. Set a small thickness and press Enter to confirm. With this new plane still selected, Shift and left-click to add the frame to your selection. Now press Shift 2 and choose Replicate Mirror. Press A to change the mirror to use the Y-axis. Press F to flip the mirror direction, followed by Enter to confirm. Okay, great. We've now got an object we can use to slice with. Let's rename it Frame Antenna Slice. Shift and left-click to add the frame to the selection again. Press Shift 2 and choose Booleans Slice. Nice one. This fancy Boolean trick is useful because it lets us change the position and thickness of the antenna lines whenever we want to. Hide the Boolean utility objects by pressing Shift 2 and choosing Viewport Utils Visibility. Select the newly created antenna lines and rename them so we stay organized. From this point onwards, we'll be using many of the same techniques we've covered so far, so I'll skip the step-by-step instructions in more places, but I'll continue to explain new techniques and points of interest in detail. The next step is to add buttons to the frame. Switching to the left view, let's add a mesh plane, resize it, and align it to the current view. Tweak the height and apply the change to scale. We'll reposition it towards the top end of the frame and out towards the left side. Let's apply a vertex bevel to round its shape. We'll give it some thickness with a solidify, and then rename it to Action Button. We can also duplicate and use this button mesh to cut a hole through the frame. This will eventually add to the overall realism, and I'll show you why this matters when we add the finishing touches to the model. Adding the other buttons is just about repeating this process several times, so I'll skip ahead and show you the results. Once all the buttons have been added and Boolean holes cut into the frame, you'll notice the mesh has some complex and messy looking polygons. Generally, this is not a problem for our hard surface modeling workflow, as long as it doesn't cause side effects. We'll briefly revisit this towards the end of the modeling process. One of the objects I've added here is actually the sim tray that sits flush with the side of the frame. We'll need to add a small circular hole to one end. You already know how this technique works. You start with a plane, add a vertex bevel to round it into a circle, then solidify it and use this to cut a hole with a Boolean. Okay, let's model the fluff catcher next. This one will be a standard USB-C. Again, we start with a plane, round it with a vertex bevel, solidify, then Boolean the hole into the frame. We add another solidified plane for the receptacle. I didn't know it was called that either, and it's probably best we don't tell anyone. Our other dirty little secret is that the USB-C port is probably deeper in reality, but I'm going for a nice render, not accuracy. It should also now be pretty obvious why we created a body mesh to fill the inside of the phone. There are usually small screws either side of the USB-C port. So we add a plane, round it with a vertex bevel, and then solidify. I'm going to rename this screw cutter. These screws are placed symmetrically either side of the port. ND can help us with this step, so hold down Shift and left-click the frame to add it to the selection. Press Shift 2 and choose Replicate Mirror. In this case, we just need to press F to flip the mirror direction. Press Enter to confirm. We also need to Boolean these holes into the frame. To create the actual screws themselves, you can select the Screw Cutter Boolean utility, then press Shift 2 and choose Boolean Hydrate. Scroll your mouse to select the model collection and press Enter to confirm. We can rename this mesh to Screws. Adjust the solidify until the screws are flush with the outer surface of the frame. Hide the utility objects. To add screw heads, ND has yet another trick up its sleeves. Press Shift 2 and choose Sketch Screw Head. Hold down Alt and bring the scale down to something more usable. You then scroll to cycle through a range of common head types and press Enter to confirm. Rename this to Screw Head Cutter. Solidify this and then Boolean into the screw. You'll notice the Boolean doesn't mirror to both screws, but it's easy to fix this by inspecting the modifier stack. Simply drag the mirror modifier below the difference Boolean. The next detail we need on the frame is a set of holes for the microphone and speaker. I'm just going to model holes and not worry about adding a mesh grill detail. You'll need to use the same kinds of techniques and operations we've already learnt about. Rename this to Grill Cutter. We're going to need a row of these holes, and luckily ND has a helper for this too. So press Shift 2 and choose Replicate Array. Increase the count and hold down Control to adjust the offset so they sit more closely together. Press Enter to confirm. You already know how to mirror these to the other side, so go ahead and do that. Then Boolean them into the frame. We've now finished adding all the components to the frame. We've used a series of fairly similar techniques comprised of mainly booleans and bevels. Take a look at the modifier stack for a moment. If you think about the fact that we started with a simple flat plane, it's pretty impressive what you can achieve with a combination of modifiers. There's quite a few of them, so it's a good idea to do a sanity check on the order of operations. ND tries its best to organize things, but I've spotted a couple of aspects that are worth changing. ND places a weld modifier directly after a bevel to clean up, just in case any edges or vertices end up on top of each other. So you should drag the weld modifier that has wandered off back into position below the second bevel in the stack. I can also see that if I toggle the last difference boolean on and off, that the frame in a cutter would be better placed as the first boolean operation. Let's turn the visibility of the other parts back on. It's looking good, so let's finish this model by adding the cameras and the last few details. We can use all the basic techniques we've learnt so far to construct the lens frames and lens covers. I'm going to keep the design of this very simple for the tutorial, but you should experiment and have a bit of fun with your own design. Luckily, it's much easier to try design changes thanks to modifiers. With the basic parts in place, it's time to try a couple of new techniques for the lens and lens barrel. We'll need the 3D cursor placed centrally, so select the Camera A frame and press Shift-S and choose Cursor to Selected. Switch to Side View and toggle X-ray view on by pressing Alt-Z. We're going to draw the profile of the lens barrel. This is the black plastic shaped like a cone that surrounds the lens itself. Once we have the profile, we'll use this to revolve or sweep around in a circle to form the conical shape. Press Shift-2 and choose Sketch, Single Vertex. This literally places a new mesh with a single vertex at the 3D cursor position. Enter Edit Mode, and with the vertex selected, press E to extrude. Hold down Ctrl to snap to the grid and move the new vertex into position. You can also hold down Shift to use smaller snapping increments. Repeat this a couple of times to form the full profile of the lens barrel. You'll probably need to tweak the positions of the vertices a few times. That's totally okay. We'll also need to select the first two vertices and move them away from the center a bit to make room for the lens. Let's head back to object mode. When we switch to perspective view, we'll toggle off X-ray by pressing Alt-Z and also hide the lens cover. Making sure that you have the new mesh selected, press Shift-2 and choose Extrusion Screw. This will sweep the profile around. So increase the segments and then press Enter to confirm. You can also tweak the profile if you need to. Rename this mesh to Camera A Barrel. The next step is to add a spherical lens itself. The typical way to achieve this is by simply adding a sphere primitive, then squashing it down a little bit flatter. It's totally fine to do this. In fact, sometimes it makes a lot of sense to use multiple types of approaches, such as polymodeling or subdivision surfaces, and mixing them together with a non-destructive modeling workflow to achieve the results you need. Use the best tool for the job. However, I do want to show you a little trick. It's actually possible to create a sphere that is non-destructive, and that allows you to change its resolution flexibly. With the 3D cursor still sitting in place, press Shift-A to add a cube primitive. Next, press Shift-2 and choose Bevels, Bevel. Increase the width and press C to toggle on Clamp Overlap. You should have a diamond shape, but if you increase the segments, this will turn it into a sphere. You'll probably never look at the default cube the same way again. Believe it or not, you can actually get even more procedural than this. It's possible to create a sphere by starting with a single vertex, and then using only modifiers to create the shape. If you want to know how, check out our video demonstrating single vertex primitives. From here, it's just a case of resizing and scaling the sphere into a flatter lens shape. Normally, we would also apply the scale change, but this is one specific use case where we shouldn't. Let's rename this Camera A Lens. It's time to tidy up our outliner view. Hold down Shift and drag the barrel and lens onto the Camera A frame to parent them to it. While you're at it, you may as well parent all the other objects to the frame. To create a second camera, we can duplicate this one. But first, we need to re-enable the Boolean utilities, otherwise Blender will ignore them. With the camera A frame selected, press Shift-2, then hold down Shift again, and choose Viewport Utils Visibility. This special mode sets all utility objects for the selected object to visible. You should see that the camera A frame cutter is now visible. Next, we right-click on the camera A frame in the outliner and choose Select Hierarchy. This makes sure that Blender will duplicate all the pieces we need. Back in the 3D viewport, press Shift-D to duplicate, then press Y to constrain it to the Y-axis whilst moving it into a new position. Left-click to confirm. You may want to adjust the position and rename all the duplicated objects so everything stays nicely organized. I'm also going to hide the utilities and hide the lens cover for a moment. Tweaking the lens barrel to make this second camera look like a wider angle lens is also a good idea. Well, that rounds out all of the modeling techniques I'm going to show you today. The good news is that these fundamentals are the key techniques used for non-destructive modeling in Blender with ND. You'll be able to take what you've already learnt and apply it to many other modeling tasks. To finish the mobile phone, you'll need to use the exact same techniques. Let's take a look at the last few details. I've added an LED flashlight, which has been cut and recessed into the rear panel. And I used a jagged profile sketch, followed by a screw operator to form the plastic covering. On the front of the phone, I've cut a rounded window into the display, much like you see on an iPhone. The difference is that this so-called dynamic island actually lives up to its name thanks to the modifier stack. I've also added a small front camera. There are usually other sensors and small components in this area, but they're never really visible, so I skipped modeling them. But the front camera lens sometimes catches a highlight, so it is worth including. For the final touches to the model, we should consider adding a small edge bevel to several parts of the phone. Select the frame, press Shift-2, then hold down Shift again, and choose Bevel's Bevel. This special mode stacks an additional bevel modifier instead of recalling the existing one. In this way, we can have a large bevel to define the main profile of the frame edges, followed by a smaller bevel afterwards. If I enter a small value, everything seems fine so far. But if I press C to enable clamp overlap, we notice the bevel shrinks to avoid an overlap somewhere on the mesh. This does sometimes happen, and it's just the nature of this type of workflow. So what can we do? I want to hide the other objects so I can focus on the frame. If we inspect the mesh closely, what we're looking for is any stray vertices or very short edge lengths. Usually this is a problem caused by a Boolean operation. So I'll disable all of the Booleans and re-enable them one by one to find the culprit, watching carefully to see when the bevel gets clamped. If we look at this closely, we can see that the bevel gets clamped by this short edge and is prevented from growing any larger. There are several possible ways to fix this, such as adding more edge loops or subdivisions to the original geometry in a tactical way, or tweaking the placement and shape of the Boolean cutters, and in cases where the problem edge is very small, a weld modifier could do the trick. But this is a large topic we'll need to explore in another video. For now, we need some kind of quick fix. So the easiest thing to do is to drag the bevel modifier and its associated weld higher in the stack before the problematic Boolean. I would like the bevel to affect the frame edges and the antenna lines and the USB port, but not anything else. So I tweak the order of operations to get the result I want. For the other parts of the phone, I add an identical bevel to the plastic antenna lines themselves, and some small bevels to several other parts. These won't present any problems as they're much simpler than the geometry of the frame. For the SIM tray and screws, we're going to add a fine edge bevel using a shader technique, but we'll take a look at that later. The very last step in the modeling process is to turn off the wireframes and check our results. Overall, it looks really good. But remember those messy diagonal edges and stretched out polygons running across the frame? Unfortunately, they're causing shading issues. You may not be able to see this due to video compression, but it'll definitely be a problem if we want to make the frame a reflective material. Understanding why this happens depends on your deeper knowledge of how surface normals actually work. That's a topic for another day. Luckily, there's a modifier that helps us control the normals and fix the shading. Press Shift 2 and choose Shading, Weighted Normals. That's much better. We should do the same thing for the antenna lines because they follow the same profile. We've used a variety of modeling techniques using modifiers to construct our geometry. Because of this, it would be a good idea to check our normals are still facing in the right direction. Press Shift 2 and choose Utils Face Orientation. Faces shown in blue are what we need, but if any are in red, we'll need to flip them to face the other direction. On the back, I can see the LED flashlight is red, so select it and press Shift 2 and choose Extrusion Screw to recall the operator. Press F to flip normals and press Enter to confirm. This tends to happen with the screw operator because it depends on the direction it was constructed in. Fix any others that you come across. And with that, we've completed the model. Let's bring all that hard work to life with a nice render. We'll need to do a little bit of preparation first. I like to keep my source geometry from the modeling phase separate to the geometry I use for export or rendering. In the outliner, right-click on the model collection and choose Duplicate Collection. Rename this duplicate to Render and hide the model collection. At this point in our workflow, we might have to leave the non-destructive approach behind. Blender isn't a fully fledged parametric or procedural software, at least not yet, so we can't do everything this way. We need to be able to UV unwrap the model, which we can't really do unless we apply the modifiers. This is totally okay though, because you have to be done with the modeling at some stage, commit, and then move on. But we're smart, so we only go destructive in a duplicated copy of the original model. You can apply the modifiers in the stack manually, but ND has a useful utility for this. Just make sure you're working with the objects in the render collection. Then in the outliner view, right-click and choose Select Hierarchy. Back in the 3D viewport, press Shift 2 and then hold down Shift again and choose Utils, Apply Modifiers. There's two modes to this utility, and holding down Shift just ensures the entire modifier stack is applied. If you inspect all the objects, you'll see that ND has flattened all the modifiers down. Now we need to UV unwrap the display mesh. Hide the glass so we can see what we're doing, then select the display. Let's switch to the UV editing workspace. In edit mode, ensure you have the whole mesh selected and press U and choose Unwrap. If you want the UV coordinates to be centered in the square, make sure everything is selected in the UV editor, then press N to open the UV vertex sidebar and set the X coordinate to 0.5. That's it, so exit edit mode and switch back to the layout workspace. Then toggle the glass visibility on again. Good lighting is really the key to a good render. Phones have a lot of glossy surfaces, so we'll need to carefully control our lighting and pay close attention to reflections. We're going to take some inspiration from professional product photography and use a technique called gradient lighting. But first, some basic setup steps. Let's start by adding a backdrop. Press Shift A to add a plane, then position and rotate it to sit a reasonable distance behind the phone. I'm going to rename this Backdrop. We're going to use an area light to cast a soft gradient on this and ensure the silhouette of the phone reads easily. Press Shift A and add an area light to the scene. Position and rotate this to light up the backdrop. Press Shift A and add a camera. Position and rotate this to face the phone and the backdrop. Because we're working at a small scale, the camera gizmo looks giant. So change this in the Camera Data tab by adjusting the viewport display size. Switch over to the camera perspective view to take a look. Okay, great. We should probably rotate the phone so we can see it better. In the Render tab, set the render engine to cycles and enable GPU compute for the render device. Switch the viewport shading to rendered. The area light on the backdrop is definitely too bright, but we have to fix something else first. By default, you can see there is also an evenly distributed dull grey lighting in the scene. This lowers the overall contrast in the blacks and shadows in particular. So let's disable it in the World Settings tab by turning the World Surface Strength down to 0. I'm also going to adjust another viewport display setting in the Camera Data tab. This one is called
Passepartout, passepartout.
which is a French word that means something in French, but for the rest of us it means Cycles won't waste as much time rendering the whole 3D viewport outside what the camera can see. This works as long as we increase the value to 1. Let's adjust that area light to a lower value and make it smaller. We can also adjust the beam shape spread to achieve a bit more contrast across the backdrop. Okay, so this is looking pretty moody and dramatic. It might even be a nice way to start a product reveal animation where we can see the silhouette first. The next step is to light the phone itself. These light sources are very important because they'll be clearly visible on the reflective metal and glass surfaces. Switch over to solid viewport shading and break out of the camera view so we can get a better view of the scene. Press Shift A and add another area light. Position this to the left and rotate it to face the phone. Let's change over to the shading workspace. Make sure the 3D viewport is viewing from the camera and enable rendered viewport shading. In the outliner, right-click on the phone and choose Select Hierarchy. This makes sure we've got all the parts of the phone selected. In the Material tab, let's add a new material called Metal. Blender doesn't apply this to all the selected objects for us. So in the Object menu, choose Link, Transfer Data, Link Materials. We'll make other materials, but having the same material applied to everything temporarily will help us tweak our lighting and reflections. In the Material tab, increase the metallic to 1 and lower the roughness to 0 so we get a perfect reflection of the light source. Go ahead and rotate the phone around. What you'll notice is that we can clearly see the edges of the area light. It's a solid, even brightness, and overall, this looks harsh and unnatural. Of course, you could increase the roughness of the metal to soften things, but this won't work for the glass, where a higher roughness might end up making it look like plastic. Instead, we need to soften the light source itself. Switch to Front View and select the area light. By default, light sources aren't directly visible to the camera itself. So in the Object tab, toggle on Camera Ray Visibility. To soften this harsh white square, we need to create a simple custom shader. Click Use Nodes to enable the shader editor. I'm going to plug in a procedural gradient so we have lots of control within Blender, but you could also use any kind of image with a soft gradient. Press Shift A and start typing Gradient Texture to select and add this new node. Set the type to Quadratic Sphere and connect this to the emission strength. You should be able to see a radial gradient, but it's very subtle. Let's go ahead and add a texture coordinate node to tell it to use UV coordinates, then a mapping node to control how its transform, position, rotation, and scale are actually applied. Set the type to texture, and then offset the X and Y location and adjust the X and Y scale. These values position the radial gradient in the center of the light and end up creating a nice soft edge. To gain a bit more control over the gradient, let's add a color ramp node after the gradient texture node and use the ease interpolation. Switch the 3D viewport to camera perspective so we can see what this looks like in the phone reflections. As you can see, the reflection is now much softer, and if we play with the color ramp, we have quite a lot of control over the quality of the reflections. The next step is to duplicate this area light 3 more times and arrange them around the phone so there is one for the left, right, above, and below the phone. All of them should point inwards towards the phone. Let's jump ahead and see what this setup looks like. Orienting the phone in different directions yields good results, where the reflected gradients wrap softly around curved forms and provide smooth transitions across large flat surfaces. This is a great lighting setup for our phone to be rendered from almost any viewing angle, and we can easily tweak the gradient parameters to refine the look. We should also make a few more small tweaks to improve the results. Adjusting the power of each area light independently allows us to give the lighting a better key direction. It may also be a good idea to reduce the beam shape spread angle to avoid any unintended spill of light onto the backdrop. Adjusting the angle can also work to control the light and reflections on the phone itself. The lighting technique we've used here works well to produce soft gradient reflections. The key takeaway here is that if you want nice smooth reflections, you need to control the light sources and surfaces that are actually being reflected. The materials for the phone are mostly pretty simple. However, we do need to talk about a special shader workaround I mentioned earlier regarding the SIM tray and screws. We'll apply this technique to the metal material. But before we get to that, you'll need to increase the metal material's roughness to something like 0.4 if you want it to look more like aluminium. I'm going to zoom my 3D viewport in really closely so I can see the SIM tray, which right now is only visible because of this hole. If you remember our modeling process, we added small bevels to some of the phone parts, but were limited by how small we could go due to a few minor issues with the underlying geometry. We couldn't add a very fine bevel to the SIM tray and screws in order to highlight their edges properly. So how do we overcome this? Luckily for us, there's a handy shader technique to the rescue. FYI, this is a cycles only shader. Making sure you are editing the metal material shader in the shader editor, press Shift A and add a bevel node. Connect the output to the normal input of the principled BSDF shader. Lower the radius to a very small value to suit the smaller scale we're working at. Increase the samples to at least 8 for a bit more definition. Now we can properly see how the SIM tray is integrated tightly and flush within the frame. And we can also see the edges of the screws properly. The bevel shader works with the specified edge radius, altering the shaded normals to achieve a rounded appearance. This does not modify the actual geometry. The rest of the materials are very simple. Because the principled BSDF shader is a bit of a superhero that can do it all, it's easy to create a new material for the glass with no or very low roughness and with the transmission weight set to 1. You can utilize this material for the camera lenses and lens covers too. Let's take a look at the screen display material. For this, we need an image texture node with a mapping and texture coordinate node to control the UV coordinates. A phone screen lights up, of course, so we need to pipe the texture into both the base color and emission color inputs of the principled BSDF. Turn up the emission strength to about 1. You may need to tweak this value depending on the brightness of your screen and your colors. In the modeling process, we also created a body mesh to fill the inside of the phone. This is visible around the edges of the display, around the front camera, and when looking into the USB-C port and a couple of other places. With that in mind, it will need a plain black material with full roughness. And to totally eliminate any remaining reflections, set the specular IOR level to 0. There are a couple of other materials and small details you can easily apply yourself. And with that, we're all done and ready to render. If you've enjoyed this tutorial today, please give us a like so we can reach more people, and consider subscribing for more. If you have any questions, leave a comment below, or join our Discord to connect with us and other ND add-on users. Through the process of creating a mobile phone, we've explored a range of useful non-destructive modeling techniques that can be applied to many hard surface modeling tasks. There's more to explore with ND, including a few additional operators, shortcuts, and handy utilities. But most importantly, I want to emphasize how this kind of workflow affords you the ability to make changes flexibly. For me, this has meant less time wrangling topology and more freedom to explore the actual design of hard surface 3D forms. There are, of course, pros and cons, but this approach is a huge win for me personally. I hope you have some fun tweaking the design of your mobile phone and consider adding a non-destructive modeling approach to your Blender skills.